The wrapping function. This circular function is called the wrapping function, where the domain is the set of real numbers and range is the set of points on the unit circle. By the unit circle, we mean the circle with a radius of 1 with the center at the origin of a coordinate system. In defining the wrapping function, we wrap a real number line starting at coordinate 1, 0, which is the origin, around the unit circle. The positive axis is wrapped counterclockwise and the negative axis is wrapped clockwise. In this way, each number on the number line is paired with a unique point, called a circular point, on the unit circle. To locate the circular point associated with a number such as 47 or negative 74, the number line is wrapped many times around the circle. Another way of pairing real numbers with points on the unit circle is to think of arc length. To find a point on the circle, we start at origin 1, 0 and move x units along the unit circle, counterclockwise if x is positive and clockwise if x is negative. It is important to be able to find the coordinates a, b of a point on the circle and the arc length x, so that we can write that function w of x equals a, b. This is usually difficult and requires the use of a calculator. However, for certain numbers, integer multiples of pi over 6, pi over 4, pi over 3, and pi over 2, we can find the exact coordinates of the corresponding circular points using simple properties of a circle. We can start identifying specific coordinates for those numbers by finding the circumference, which is 2 pi r. By using the circumference formula, we can find that 1/4, 1/2, and 3/4 of the circumference relates to pi over 2, pi, and 3 pi over 2. So, if x equals 0, the point is 1, 0. If x equals pi over 2, the point is 0, 1. If x equals pi, the point is negative 1, 0. If x equals 3 pi over 2, the point is 0, negative 1. If x equals 2 pi, the point is 1, 0. As you can see, these are all points on the x and y axis. We can find the coordinates of any circular point only if they correspond to a real number that is a multiple of pi over 2. The most common integers seen on the unit circle are pi over 6, pi over 4, pi over 3, 2 pi over 3, 3 pi over 4, 5 pi over 6, 7 pi over 6, 5 pi over 4, 4 pi over 3, 5 pi over 3, 7 pi over 4, and 11 pi over 6. It is easy to see that the wrapping function is not a one-to-one function. Each domain value, a real number, corresponds to exactly one range value, a point on the circle. However, each range value, a point on the unit circle, corresponds to infinitely many domain values or real numbers. For example, we see that when x equals pi over 2, its coordinate is 0, 1. That is, exactly one range value corresponds to the domain value pi over 2. But how many domain values correspond to the range value 0, 1? Every time we go around the unit circle 2 pi units in either direction from 0, 1, we return to the same point. Thus, if we are asked to solve what value of x corresponds to the coordinates 0, 1, we have to write x equals pi over 2 plus 2 pi k, and there are infinitely many domain values of x that correspond to the range value 0, 1. So the wrapping function property is that for all real numbers x, w of x equals w of x plus 2 pi k, where k can equal any integer.